All right, let's do bromine. Number 35. Energy level. Black. How many squares? 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 Anybody not know where we are right now? Magnesium. Okay, keep going straight across. The towers are the same, so it's still energy level. Black. 6 squares. Where am I now? Argon. Okay, so I go to the beginning of the next line. It's energy level. Black. Squares. You still keep going across, but it's the energy level that drops. So now it's energy level 3. It's not 4. So it's, well, I'm going back to 3, yes. 3, D, 10. There's 10 squares in the 10 section, in the D section. What element am I right now? Zinc right now. You said you don't get this.
Which element were we going?
Oh, okay. We are heading for bromine.
Oh, okay.
So then we go back to energy level 4?
So now we're on energy level 4. P block. 5.
Wow, that's a lot of crap up there.
It looks really scary, doesn't it?
Yeah.
But once you know how to read it, though, it's easy. Can you see why I couldn't finish this on Monday? Okay.
Do we get the cheat sheet?
Yes. Wait, what?
Do we get a cheat sheet?
You get the green cheat sheet and you get a periodic table.
Without the SP.
Right. Okay, so let's. Do you want to do another one like this, or you want me to do one harder?
Sumerian.
Another one sunk down? The second sunk? Because the F's, remember, fit in the inner transition. They are inner transition. They fit in the transition elements, but they're also sunk down. I'm going to do one. Let's do one of those. Yeah, that's my job. I'm kidding. Let's do erbium. My mom's maiden name is Herb. Number 68. Okay. Energy level. Black. Squares. Energy level. Black. Squares. Energy level. Energy level. Black. Squares. Energy level. Black. Energy level. Black. Squares. Energy level. Sunk down, so it's 3. D. 10. 4. P. 6. Where am I right now? 4P6.
4P6, krypton.
Krypton, yeah, one of my favorites. Okay, so then we go down to the next line and we have 5, S, 2.
4,
Yep. Okay, if I stopped here, where would I be? Cadmium, yep. Now I'm energy level.
5P.
Okay, so then I would be.
6.
Wait, hold on, where would I be?
Oh, you're on xenon.
Okay, xenon, yep. Then I'm 6.
S2.
Okay, so the next energy level, it sunk down, so it's energy level 5, D. Now nope. You can only do one. Because then you read it. Because those fit in there, remember, they fit up in there. So when you're going from number 57, you have to go to 58, which is down in the bottom, because those were too long. So then it dropped down again, sunk down again, so that's 4, F.
And I forgot where we were going to.
Going to 68 there.
11.
Yep.
11.
That's the electron configuration for erbium.
Can we use our own periodic table, or do we have to use yours?
You have to use mine.
So we have to memorize this, apparently.
You have to read it like a paragraph.
Really? It wouldn't be
Well,
that
that's not hard. That part is remembering where the other one.
Yeah, where the blocks stop, I think is what she's saying. Like
Yeah,
where the lines
that's
stop
right.
to separate S from D.
Well, no, that I know what those are.
Well, they're towers.
This, where this goes to 3, from 4 to 3. To 4.
That's, right?
That's what I'm talking about.
Do you get what she's saying? Like, you know how we numbered down the side of like from helium all the way
Yeah.
to that we're gonna find? Yeah, the sunk down part, she's not getting why the number, she's not like how to.
Right. Well, when I give you the periodic tables when you do the test, they're laminated, and I'll give you the wipe off, wipe on, mark or wet erase markers, so you can write it on it, doodle on it. Yeah. Okay, can I show you a shortcut? Do you understand it enough that I can show you the shortcut?
Yeah.
Let's do erbium again with the shortcut. So for all of these, they all started the same, right? 1s2, 2s2, 2p6, blah, 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 blah. So the shortcut is when you get down as far as like erbium, all of the noble gases, those stuck up noble gases, are full, right? They have full outer shells. They have that law of octaves reach. So the shortcut is instead of starting all the way to hydrogen, the 1s1, you can start at the noble gas that is full before the one you're looking at, and then just go from there. So if we're looking at erbium, erbium would fit in the second row from the bottom. So the noble gas that's full before it is xenon. So the shortcut is to put xenon's symbol in brackets, saying instead of starting all the way at hydrogen, we're starting at xenon, and just go from there. So if we are already at xenon and we drop down, what's energy level 6, black, and there's 2 squares. And then we are in energy level 5 because it's sunk down, the transitions are sunk down, but it's black D. And we can go 1 square until we have to drop down to the bottom again to energy level 4, black F, and then 11. So basically by starting at xenon, we took out all of this.
That's a lot of savings,
I think so.
especially you get down even further.
Yeah. Okay, the reason, this might help clear some of it up. The reason the transitions are sunk down and we have to go from 4p6 to 5s2 and then back to 3d10 is because by the time the electrons get this far away from the protons that are in the nucleus in that dense center, they start getting really excited. So they jump up in energy level, and then they realize, crap, we forgot the rest of 3, and they go back in and fill in D, 3D. So same thing here. So we went from 3p, started filling up energy level 4, yeah, we're already at energy level 4. And they're like, oh crap, we forgot 3D. So they go back, fill in 3D, and then they already filled in 4s, so they can fill in 4p. And then they're so excited they're that far away, they start filling in 5s. And they're like, crap, we forgot 4D. So they fill in 4D, and they're like, we already filled in 4s, or 5s, so then we can go to 5p. And they're like, we're already out here, so let's go to 6. So they go to 6, and they're like, oh, wait, we forgot 5D. And they start filling up 5D, and they're like, oh my gosh, we totally forgot about 4F. So then they go back in and fill 4F.
So they're like ADD.
Yes, by the time they are out that far, they have ADH,
Yes.
Yeah. So, electron configuration, is it as scary as you thought? It looks really scary. If someone walked in right now, they'd be freaked out and walk right back out.
Yeah, because I was already looking at the book going,
Yeah. Yeah. So that is electron configuration.